Hey guys, welcome to a new video. In today's video we're going to look at a Leetcode problem, and the problem's name is minimum deletions to make string balanced. So in this question we are given a string S consisting of only characters A and B. You can delete any number of characters in the string S to make S balanced. S is a balanced string if there are no pairs of indices I, j such that I is less than j and the character at I is equal to B and the character at j is equal to A. So there shouldn't be no pairs of characters B, A in the string S. Our task is to return the minimum number of deletions needed to make the string S balanced. Let's take this example and see how we can solve this question. Let's take the first example. I've taken the same example as S. Now we have to check for pairs of B, A, and B is I and A is J. Now let's iterate through the string S starting from the 0th index position until the end, and we take the character I, so I is here. Now we have to compare the current element and the next element, right? So let's store the current element into a stack so that we can make this comparison if they are adjacent, and if you find this we can remove this B and increment the count. Now let's also declare a variable count which will be our output, and initially it is 0, so count is equal to 0. Now to store this, let's use a stack. So inside the stack the elements will be added from the top and removed from the top. Now only if the stack is not empty we can remove elements from the stack. If the stack is empty, just add this character into the stack. Now stack is empty, so add that character into the stack and move forward. Now check if the topmost element is equal to B, because we are checking for I, and check if this element is equal to A. No, it is not equal to B, but this is equal to A, so we can't delete it. So add this current element I into the stack. Now I is at B. Check if this current element is equal to A. Check if this topmost element is equal to B. No, and this is also no. So add this element into the stack. So I add B into the stack and we move forward. Now I is here. Check if the topmost elements inside the stack is equal to B. Check if the current element is equal to A. Yes and yes. If that is the case, remove this topmost element from the stack. So stack.pop and increment count. It means we made one deletion, and because we find the ij pair. Now go to the next element. It is a B. Check if the topmost elements inside the stack is equal to B. Check if the current element is equal to A. No and no. Then add this element into the stack, so B is added. Now the next element is a B again. Check if this is A and check if this is B. This is B, but this is not A. So we can't delete the topmost element, so add this B into the stack, so B is added. Now I is here. Check if the current element is equal to A and check if this topmost element is equal to B. Yes and yes. That is the case, delete this element from the stack. So stack.pop and increment count and move forward. The current element is equal to B. Check if it is A. Check if topmost element is equal to B. Yes, but this is no. So we don't delete this element and we add this element into the stack, and the count is equal to 2, and 2 is the expected output. Coming to the function given to us, this is the function name and this is the string S, and the return type is an integer returning the minimum number of deletions needed to make the string S balanced. Like we discussed, first let's declare a stack which will contain characters. Now let's declare a return type that is an integer. I'm going to name it count, which is initially 0. Now let's iterate through the string S using a for loop starting from left to right, that is at the 0th index position until the end. Now we have to compare the topmost element inside the stack and the current element we are iterating in the string. So let's use a if statement. But before that we have to check if the stack is not empty, only then we can compare the topmost element inside the stack. So stack.isEmpty and not. So if stack is not equal to empty, now let's do a check of comparing the topmost element inside the stack, that is stack.peak. So the stack.peak should be the character B, right? Because first we are comparing B, and the current element we are iterating, that is s.caret of I, is an A. So if we find this pair, we can make one deletion. So remove the topmost element from the stack. So stack.pop and increment our count. And now in the else block, it means the stack is empty. If stack is empty, just add the current element we are iterating into the stack. So stack.add of of the current element s.char of I. Now this process will happen for all the characters, and we have our answer present inside this variable count, so return it. Now let's try to run the code. This has to be double equal to. Let's run the code again. The test cases are running. We can also change this to push instead of add. Doesn't make a difference. Let's submit the code. And our solution is accepted. The time complexity of this approach is big O of n because we're iterating through the string s, and the space complexity is also big O of n because we're using a stack to solve this question. That's it guys. Thank you for watching, and I'll see you in the next video.